Hello everyone and welcome back to Math 143, Finite Mathematics. In our previous lecture, we learned what matrices are and how to determine their size, how to add and subtract matrices, and how to find a transpose, also how to multiply a matrix by a scale. Today we are going one step further. We will learn how to multiply two matrices. Although the process is different from ordinary multiplication, once you understand the pattern, it becomes much easier. By the end of this lesson, you should be able to determine whether two matrices can be multiplied, multiply two matrices, explain why matrix multiplication is not cumulative, understand the associative and distributive laws, identify the identity matrix, and write a system of equations in matrix form. Okay, let's begin. Can we multiply any two matrices? Okay, let's start. Can we multiply any two matrices? Think about it. So, the answer is no. So, suppose matrix A has size m by n and matrix B has size n by p. Notice something important. The inside numbers must match. That means what? If they match, multiplication is possible. So inside numbers means this. That means what? Number of columns in the first matrix must be equals to the number of rows in the second matrix. Right? So, if the number of columns in the first matrix must be equal to the number of rows in the second matrix. Right? It must be equal. So the inside numbers must match. If they match, multiplication is possible. The results will have the size will have the size m times p. Let's see the example carefully. So, let's say matrix A 2 by 3, matrix B 3 by 4. Can we multiply A and B? The answer is yes, because the inner value here, inside value, that means the number of columns the first matrix A and the number of rows are equal. So the results would give us a 2 by 4 matrix. A 2 by 4 matrix. Okay, next. Let's say the matrix C is 2 by 3 and matrix D is 2 by 2. Can we multiply C and D? The answer is no, since 3 does not equal 2, right? The inner values are not equal. So we can't multiply that two matrices. Okay, then let's see how do we multiply. So this is the part where many students get confused. Remember only the rows multiply by columns, never row by row. Right? Okay. So how to multiply? So the important thing is rows multiply columns, never row by row, never column by column. Right? Let's say here we have matrix A. Let's say A11, A12, A21, A22. Matrix B, B11, B12, B21, B22. Right? So the rows multiplies by column. Right? That means A times B, that is A11 times B11, first one, plus A12 times B21, the first entry of the A times B. Next, let me check this. First row, second entry, then first row, second column, right? So A11 times B12 plus A12 times B22. Okay. Next, now we wanted to get the second row, first entry of the A times B. To do that, we wanted to multiply the second row, first column. Second row, first column. Second row, first column. Let me get A21 times B11 plus A22 times B21. Right? Okay, next. Okay. Second row, second column. So A A21 times B21 plus A22 times B22. Right? This is how it works. Multiply rows and columns. Never multiply row by row or never multiply column by column. Okay, here you can see the formal definition, how to get the values. And let's go for the example. The first example, 2, 1, A is 2 by 2, B is 2 by 2 matrix. So AB11, that means let's get the values. The first row, first column, 2 by 4 plus 1 by 5. Okay. Next, first row, second column. 2 by -1 plus 1 by 2. Next, second row, first column, 3 by 4 plus -2 times 5. Lastly, second row, second column. Right? 3 by -1, 3 times -1 plus -2 times 3 times -1 plus -2 times 2. Okay, let's get the values. 8 plus 5. -2 plus +2. 12 minus 10. -3, -4. What about the values? What about the values? 8 plus 5, 13. 12 minus 10, 2. -3, -4, -7. -2, 2, 0. So therefore, here you can see that AB11, AB12, AB21, AB22. So the values are 13, 0, 2, and -7. This is how we can multiply the matrices. Right? Let's go for the one more example. Let's take A equals 1, 2, B equals 3, 4. First check the size. 1 by 2, 2 by 1. What size is the answer since 1 by 2 and 2 by 1? The answer is 1 by 1. Since 1 by 2 and 2 by 1, answer is 1 by 1. So let's compute rows, columns, right? One times 3 plus 2 times 4. 3 plus 8, 11. AB 1 by 1, 11. Okay, next. If AB exists, does that means BA is the same? If AB exists, does that means BA is the same? No, right? No. Matrix multiplication is not cumulative. We will multiply in the opposite order using the same matrices, work through the calculations. Right? So, AB does not equal BA. Right? AB does not equal BA. Check your answers here. Check your answers. Right? The answer should be 5, 6, 16 and 1. So BA 5, 6, 16, 1. AB, we got it in the previous one, 13, 0, 2 and negative 7. So therefore, AB does not equal BA. Okay. Right? Then, although matrix multiplication is not cumulative, it still satisfied several useful properties. First, the associative law. The associative law, it doesn't matter where we place the parentheses. It doesn't matter where we place the parentheses. Also, second, the distributive law. The distributive law, it says A times B plus C equals AB plus AC. So, let's see the example. Let's see the example here. You can see that AB times C. So AB, now you can quickly multiply A times B. It should be 5, 8, 1, 4. Right? And BC, you can quickly multiply 2 by 2 matrix. 6, 3, negative 2, 1. Then let's get AB times C. That is 5, 8, 1, 4 times 2, 1, negative 1, 0. 2, 5, negative 2, 1. Okay, next use A times BC 1, 2, 0, 1. BC 6, 3, negative 2, 1. So finally we will get 2, 5, negative 2, 1, which implies the AB times C equals A times BC, the associative law satisfied. Okay, then let's compute the distributive law. B plus C, quickly get the answer, 5104. Check your answers, pause the video and get the answers and check with the solutions. A times 5104 5904, right? Then given A, B and A, C here, 5904. What happened? A times B plus C equals AB plus BC. The distributive law satisfied. Okay. Let's go to the square matrix. A square matrix has the same number of rows and columns. That means the number of rows equals to the number of columns. Here you can see the example 2 by 2. So let's make one more example. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 by 3. The number of rows equals number of columns. Okay. Next. Identity matrix. Okay, what number leaves multiplication unchanged? What number leaves multiplication unchanged? So the answer should be number 1. When we multiplied the number by 1, it's just the number itself. So the identity matrix plays the same role. The identity matrix play the same role. For the identity matrix, we have a square matrix that main diagonal values are 1s, all other entries are 0. So let's say 2 by 2, which is called I2 identity matrix. The main diagonal values are 1, others are 0. 3 by 3, I3, main diagonal values are 1, all others are 0. Right? So by multiplying let's say I2 times A, it gives us A. Nothing changed. Likewise, A times I2 also A. The metric identity matrix is the matrix version of the number 1. Right? Okay. Then finally, metrics form a system of linear equations. I hope you remember that. We have written that augmented matrix. So we have been solving system of equations throughout this chapter. So instead of writing the system, instead of writing a system like this, we can organize them into 3 matrices. The coefficient matrix, 3 matrices are coefficient matrix, second variable matrix, third the constant matrix. Then we can write it down. So you can see that the matrix A here, the coefficient matrix looks like the augmented matrix without constant term. And the variables, we have x, y, z, and the constant matrix. Finally, we can write this system as A times x equals b. This notation is extremely important because later we will solve systems entirely using matrix method. Okay, so for the additional practice, I will add some examples. Multiply 2, 3 and 4, 5. Pause the video and check the answer. Right? And next example, can these matrices be multiplied? A 3 by 2, B 2 by 5. Answer: yes. The result would be 3 by 5. Example 3. Can 4 by 3 multiply 2 by 4? The answer: no, the inside numbers don't match. Example 4. Find I2 times 5, 1, 2, 4 matrix. What about the answer? The same matrix. Since the I2, the identity matrix, behave like number 1, the answer should be the same matrix. Okay, let's review today's lesson. Today we learned when matrix multiplication is defined and how to multiply matrices using rows and columns, how to determine the size of the products, and why matrix multiplication is not commutative, and the associative and distributive laws, the identity matrix, and how to write the system of equations in the form of Ax equals b. In the next section, we will continue building on these ideas and learn how matrices can be used to solve systems of linear equations more efficiently. Okay, thanks for watching and I'll see you in the next lecture.